Good day, everyone. Today we will be discussing about Pearson product moment of correlation coefficient. Last meeting we discussed about understanding correlation analysis wherein you've learned how to identify the relationship in terms of direction and strength using a scatter plot. Now, you will be using a formula in order for you to know the relationship between two variables or what we call bivariate data. So our most essential learning competency for today's discussion will be the learners calculate the Pearson sample correlation coefficient and the learners solve problems involving correlation analysis. First, to describe the relationship between two variables, we can compute the correlation coefficient R. The correlation coefficient is a number between -1 and 1 that describes both the strength and the direction of correlation. In symbol, we write R is greater than or equal to -1 but less than or equal to 1. It implies that if your answer for your value of R is equal to 2 or greater than 1 or less than -1, it implies that you got a wrong answer or maybe you have wrong solution. For value of R, if your R is equal to R, it implies a perfect positive correlation. So it implies that it is perfectly correlated to each other. The bivariate data or the two variables are significantly correlated to each other. However, if R is equal to 0, it implies that there is no correlation between the two variables. But if the value of R is equal to -1, it implies that your interpretation will be perfect negative correlation. I already discussed to you why there is a positive and negative correlation. There will be positive correlation if the value of x, as the value of x increases, the value of y also increases. However, there will be negative correlation if the value of x increases, the value of y decreases. Let us now have a correlation scale. So this correlation scale is lifted on the famous books from statistics and probability. Just want to remind you that different books have different correlation scale. They may have different ranges of value of R, but I prefer to use this correlation scale because this is lifted from a famous book from of statistics and probability. So this scale will be utilized in order for us to interpret the given value of R or the computed value of R. So we have value of R. If the value of R ranges or will fall on this range, positive negative 0.81 to positive negative 0.99, it implies that you have very high correlation. If the value of R falls in this range, positive negative 0.61 to positive negative 0.80, it implies that your interpretation will be high correlation. And if you have a value of R that falls in this range, positive negative 0.41 to positive negative 0.60, it implies that you have moderately high correlation. And if you have value of R that falls on positive negative 0.21 to positive negative 0.40, it implies that you have low correlation. Otherwise, if your value of R falls on 0.01 to positive negative 0.20, it implies that you have negligible correlation. For instance, if after using Pearson correlation and the value of R is positive 0.73, as you can see, positive 0.73 will fall on the range 0.61 to 0.80. So it implies that for the interpretation of that value of R, our interpretation will be high correlation. But since it is positive, automatic we need to indicate the direction. So we have positive high correlation, or it can be high positive correlation. For instance, the value of R is equal to negative 0.53. As you can see, negative 0.53 will fall on negative 0.41 to negative 0.60. Thus, it implies that for the interpretation of that, it is moderately high correlation. And in order for us to indicate the direction, since that is negative, we can say that we have moderately high negative correlation for that computed value of R. Now, how are we going to compute for the value of R? So we have R is equal to N summation of xy minus summation of x times summation of y all over the square root of the quantity n summation of x squared minus quantity summation of x squared, then multiply to the quantity of n summation of y squared minus the quantity summation of y squared. And then the first thing that you're going to do in order for us to simplify this, you're going to start substituting all the given values. After substituting all the given values, you will be simplifying all this one and summation of xy minus summation of x times summation of y. And then you will also simplify and summation of x squared minus the quantity summation of x squared. And then you're going to simplify also this one and summation of y squared minus the quantity summation of y squared. After that, you're going to multiply this two on the denominator and then get the square root. And then after getting that, you will divide the two, the numerator and the denominator, and then you will be getting the computed value of R. Let's try an example. This is the problem. A store manager wishes to find out whether there is a relationship between the age of the employees and the number of sick days they incur each year. The data for the sample are shown. Calculate the correlation coefficient R and describe the relationship in terms of strength and direction. So in this problem, we are finding the relationship between two variables. And what are those variables? First is the age, and that is a representation for X, or what they call the independent variable, while days is what they call RY, or what they call our dependent variable. So in this problem, we are finding the relationship between age and days. If that days represents for the number of sick days that an employee incur each year. So, bali ang tinitingnan natin dito kung if we're going to take a look on the problem, we're looking on what? We're looking on kung may kinalaman ba yung age ng isang employee sa number of sick days na nai-incur ng isang employee kada taon. So, as you can see on that table, we can never take a look by just simply observing the data. We can never um, identify the relationship exists between the two variables unless we're going to use the Pearson product moment correlation of coefficient. Let's now have the computation. So first thing, you're going to write the value of X, or the age. If the age is 18, the number of sick day leave for sick is 16 days. If the age of the employee is 26, the number of leave for sick days is 12. If the age is 39, they have 9 days sick leave. If the age is 48, they have 5 days sick leave. And if the age is 53, the number of days sick leave is 6. And if the age is 58, there are only 2 days sick leave. So the first thing that you're going to do, you're going to compute for x squared. It implies that you will multiply all the values of x by itself. So we have 18. So in order for us to get the value of 18 squared, you will multiply 18 times 18. So 18 times 18 is 324. The next value for x is 26. So 26 times 26 is equal to 676. Next is 39. 39 times 39 is equal to 1521. Next is 48. 48 times 48 is equal to 2304. Next is 53. 53 times 53 is equal to 2,809. And then we have 58. 58 times 58, we have 3,364. We already completed all the values for x squared column. Now let's have for y squared. For y squared, we're going to multiply the value of y by itself. So we have 16. 16 times 16 is equal to 256. 12 times 12 is equal to 144. 9 times 9 is equal to 81. 5 times 5 is 25. 6 times 6 is 36. And 2 times 2 is equal to 4. Now we already have the value for y squared column. Now to have the value for xy column, we're going to multiply x by y. So we have 18 times 16, we have 288. 26 times 12, we have 312. 39 times 9, we have 351. 48 times 5, we have 240. 53 times 6, we have 318. And 58 times 2, we have 116. Now, in order for us, the next thing that we're going to do, we're going to get the summation of each column. So let's start getting the summation of x. We're going to add all the values in x column, 18 plus 26 plus 39 plus 48 plus 53 plus 58, we have summation of x, which is equal to 242. Now let's add the y column. 16 plus 12 plus 9 plus 5 plus 6 plus 2, we have summation of y, which is equal to 50. For summation of x squared, you will be using the same format. You're going to add all the values for x squared. So it will be summation of x squared is equal to 10,998. Then we have summation of y squared, which is equal to 546. And then adding all the values for xy column, we have 1,625. Now, since we already completed all the values in this table, we're going to use the formula. So we have this formula, r is equal to n summation of xy minus summation of x times summation of y all over the square root of the quantity n summation of x squared minus summation of x squared times n summation of y squared minus the quantity of summation of y squared. Let us now start with substitution process. So instead of writing n, you're going to count the number of values. So as you can see, the number of values that we're talking is, or the number of employees that we're talking is 6 employees. So therefore, our n is 6. So therefore, we have 6. So instead of writing summation of xy, we're going to write 1625. So multiplied 1625. Why? Because our value of summation of xy is 1625. You're going to take a look on the summation because all those values will be used on this formula. Minus summation of x. Take a look. What's the summation of x? Our value for summation of x is 242. So therefore, we have 242. Multiplied by summation of y. So instead of writing summation of y, our summation of y is 50. Next, all over. And then put a square root. Then substitute. Instead of writing n, we will be writing 6. Instead of writing summation of x squared, as you can see, our summation of x squared is 10,998 minus summation of x quantity squared. Our summation of x is 242. So we're dealing with 242 squared. Then multiplied by 6, which is n, times your summation of y squared. Your summation of y squared is 546. So instead of writing summation of y squared, you will be writing 546 minus 50, which is your summation of y, and then write squared. So already done with the substitution process. Like what I told you, you're going to press on your scientific calculator as is. So to solve first, we're going to solve 6, quantity 1625, close parentheses, minus 242 times 50, and then we will be having negative 2,350. Now, let's multiply 6 by 10,998 minus 242 squared. If you're going to press this on your calculator, you can write 242 times 242. So it can be 6, open parenthesis, 10,998 minus, open parenthesis, 242 times 242, close parenthesis. So our answer is 7,424. So we write 7,424. Next, we're going to solve the next part. 6 parenthesis 546 minus parenthesis 50 times 50 close parenthesis equals, we can have 776. Now, the next is you're going to have this one. But after the, dividing negative 2,350 on the denominator, you need to simplify first the denominator. So you're going to have square root of parentheses 7,424 times 776 close parentheses, and then you can have 2,400.2133. Now, we can now simplify this. Divide the numerator by the denominator. Negative 2,350 divided by 2,400.2133. And the answer is R is equal to negative 0.98. So therefore, we have very high negative correlation. Now, how are we going to interpret a very high negative correlation of our given problem? It implies that if you're going to take a look, since it is negative, like what I told you, if we have negative correlation, as the value of x increases, the value of y decreases. So it implies as the value of, or as the age increases, the number of sick leave decreases. So since it decreases, it implies that kapag mas matanda, mas konti yung sick leave. Pero pag mas bata, mas marami ang ini-incur na sick leave. So does it implies if you're going to be the store manager, better na kunin natin yung mga employee, yung mga matatanda kasi konti lang yung sick leave nila. Tama? Okay, so let's now have the next example. But in reality, in our current situation today, medyo delikado na sa mga pag matatanda na. Siguro dahil masisipag kapag matatanda. Okay? Let's now have the next one. For this example, we're dealing with the relationship between the attitude score of students in mathematics and their achievement in mathematics. So this is one of the common problems inside the classroom. They are talking that if the attitude of the student is in this subject is not good, it implies that their achievement in mathematics will also be not good. It implies that they can get a very low score in the achievement in mathematics. However, there are also some researches that said that attitude score doesn't have relationship, or it's not significantly related with the achievement in mathematics. Let's take a look with our given data. Again, we're going to start writing the value of x squared. So our x is 48, 48, 47, 46, 46, 43, 42, 42, 41. Maybe they get the attitude score using a Likert scale or using an instrument wherein the students were going to assess, or they're going to check, or they're going to answer a Likert scale wherein they're going to assess themselves regarding their attitude in mathematics. And this achievement in mathematics may be dealing on the achievement score in mathematics examination. Let's now have the x squared. So we have 48. 48 times 48 is 2,304. Again, we have 48, and that's 2,304. Next is 47. 47 times 47 is 2,209. Next, 46. 46 times 46, we have 2,116. Again, next is 46. 46 times 46 is 2,116. Next is 43. 43 times 43 is equal to 1,849. Next is 42. 42 times 42 is equal to 1,764. Next is 42 again. We have 42 times 42, which is equal to 1,764. Next is 41. 41 times 41 is equal to 1,681. Next column is y squared. For y squared, we have 22. 22 times 22 is, we have 484. 19 times 19, we have 361. 20 times 20 is 400. Again, 400. For 17, 17 times 17 is 289. 21 times 21, we have 441. Again, 21, we have 441. We have 19. 19 times 19 is equal to 361. And 17 times 17 is equal to 289. Now, for xy column, we're going to multiply x by 1. 48 times 22, we have 1,056. 48 times 19, we have 912. 47 times 20, we have 940. 46 times 20, we have 920. 46 times 17, we have 782. 43 times 21, we have 903. 42 times 21, we have 882. 42 times 19, we have 798. And 41 times 17, we have 697. Now, after this, we're going to get the summation of all the values in each column. So, for the summation of x, we have 403. For summation of y, adding all the values in y column, we have 176. Adding all the values in x squared column, we have 18,107. Adding all the values in y squared column, we have 3,466. And adding all the xy column, we have 7,890. Now, all that values will be used on the formula R is equal to n summation of xy minus the quantity summation of x times summation of y all over the square root of n summation of x squared minus the quantity of summation of x squared multiplied by n summation of y squared minus the quantity of summation of y quantity squared. The first thing that you're going to do is, let us now substitute the given values to the given formula. So what are we going to do? Instead of writing n, we're going to write 9. Why is it 9? You're going to count this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have n, which is equal to 9. Now, so instead of writing n, we're going to write 9. So this is 9. Now, instead of writing summation of xy, this one, our summation of xy is this, 7,890. So instead of writing that, we're going to write 7,890. Now, instead of writing and then bring down minus this one, instead of writing summation of x, we have this one. Summation of x is equal to 403. So that's the reason why we have 403 here. Now, instead of writing summation of y, we have here this one, which is 176. Now, write the square root, and then instead of writing, and again, we're going to write 9. Instead of writing summation of x squared, we're dealing with this one, summation of x squared, which is 18,107, this one. And then instead of writing summation of x, our summation of x is 403. That's the reason why we have 9, quantity 18,107 minus 403 squared. Next is multiplied by 9, which is this one. We're here now. 9 times summation of y squared. Your summation of y squared is this one, 3,466 minus 176 squared. Now, we're going to start simplifying first this one. And then after that, we will be simplifying this and this one. So let's now have the simplification. So we have 9 times 7,890 minus the quantity 403 times 176. We will be having 82. Next, bring down, or copy the square root, and then simplify 9 times 18,107 minus 403 squared. 403 squared, if you don't have scientific calculator, you can have 403 times 403. And you have 554. For this one, 9 times 3,466 minus 176 squared. Again, if you don't have calculator, you can write that as, or press 176 times 176, and you have 200. So simplifying this whole, we have 218. So 9 times 3,466 minus quantity 176 times 176 is equal to 218. Now, let's simplify. But we can still simplify the numerator by the denominator. We're going to start simplifying first, or we're going to simplify first the denominator. So pressing on your calculator, we have the square root of the parentheses 554 times 218. So you can press that square root of the parentheses 554 times 218. We have 347 point, this one, 0.52266. Now, we can now simplify the numerator by the denominator. 82 divided by 347.52266, we have r, which is equal to 0.24. If we're going to take a look on our scaling, correlation scale, 0.24 lies on the range 0.21 to 0.40. And the interpretation for that is low correlation. And since this is positive, therefore, our interpretation will be low positive correlation. So it implies that there's just only low positive correlation between the attitude score and the achievement in mathematics of the students. Okay, let's now have the next one. Okay, now in order for you to double check your answer in of your computation in Pearson product moment correlation of coefficient, you can use the Microsoft Excel. Now how? First thing that you're going to do, you're going to open your Microsoft Excel. After that, you're going to write or encode all the values of x and all the values of y here. So we have, this is our previous example. So we have 18, 26, 39, 48, 53, and 58. And then for y column, we have 16, 12, 9, 5, 6, and then 2. What are you going to do? You're going to press equal. So as you can see this one, I press equal, and then I press this one, f of x equals, and then after pressing equals, you're going to press f of x. And then if you're going to press that, we will be having this one. This one. Now, you're going to take a look on Pearson. If there is no Pearson in this one, you're going to press this below button and then press statistical. And then after pressing statistical, Then you're going to, I'm so sorry. And then what are you, then you're going to find the Pearson. Okay, again, I'm going to repeat. Press equals, and then after pressing equals, you're going to press f of x on your Microsoft Excel, and then we will be having this one. And then after that, if there is no word Pearson in this one, you're going to press the below button here. And then you're going to check or find for the word statistical. And then after finding statistical, press that statistical. And then if you're going to press statistical, there will be average and so forth and so on. You're going to take a look on Pearson. And then press Pearson. Now, after that, you will be pressing Pearson. After pressing Pearson, there will be um, function arguments like this one. For array 1, you will only drag from your mouse from this one up to this one. Or you can write B2, since this is A2, up to A7 for array 1. So array 1 will be your X values. And then for array 2, this is array 1. And then for array 2, that's your Y values. So as you can see, it starts from B, since this is B2. So I have B2 up to B7. So you're going to have this one. So we have A2 up to A7, this one, for array 1. And we have, for array 2, we have B2 up to B7. You can drag that. After that, you can press this one, OK. After pressing OK, you will be getting the value of R. As you can see, the value of R is negative 0.98, and we get that on using our long computation. So again, I'm going to repeat. If you want to check your answer using a Microsoft Excel, you can use this pattern, or you can use what I discussed in this slide. So that's all. Thank you, and God bless everyone. So don't forget to subscribe on our channel. Hit the notification bell button so that you will be updated with our video tutorial. Thank you, and God bless.